Okay, welcome to class viewers, still on sequences. In the last video, I explained how we can get the rule of the sequence. I explained what the nth term is, how the connection has relationship with the position of the sequence. And so now the example on board is to find the nth term formula for the following sequences and also calculate the 50th term. We have 4 sequences on board, and if we look at the first one, we have 8, 16, 24, and 32. So let's start from the first one, viewers. 8, 16, 24, 32. Okay, so if we look at this sequence very well, we discover the connection, which is the rule between the term is add 8. When you add 8, you produce the subsequent term. So the first term, which is the starting point, is 8. And the rule, which is the relationship between the term, is add 8. And the nth term formula for this sequence is, I told us to get the nth term, we're going to write the rule. The rule is 8. We multiply it by n. We multiply the rule by n. We multiply the rule by n. And if there is any difference between the rule and the first term, then we will know if we are to add to what we already have or we are to subtract. But in this case, the rule and the starting point, which is the first term, they are the same thing. It's figure 8. So we're not going to add or subtract any number. That rule, which is 8 multiplied by n, gives 8n. And that's the n term for this particular sequence. Now we can move on to calculate the 50th term of the sequence. So viewer, for the 50th term of the first sequence, we're going to write the nth term is 8n. So where we have the n, we'll supply 50 there. So it's gonna give us 8 by 50, which is 400. So the 50th term of this sequence is 400. Because since the nth term is 8n, the 50th term will be 8n. You now replace n by 50. I get what I'm saying? So in other words, this is the nth term. 8n is the nth term. So for the 50th term, we have 8 multiplied by 50. So I move to the second sequence, which is 11, 22nd, 33rd, and 44. From the question, it is 44. Yeah, it is 44. It's 11, 22, 33, 44, and so on. So the starting point, which is the first term, is 11, and the rule, which is the connection of the relationship between the terms of the sequence, is add 11. If you look at it, you discover adding 11 produce the subsequent term. So for the nth term formula now, we write the rule, which is 11 multiplied by small letter n. And since the starting point and the rule is just the same thing, there is no thing to do than to just give what we have here, 11 by n, 11n. We're not going to add or subtract any number. When the rule and the starting point are the same, it makes the work easier. You just pick the rule and multiply by n. That's just for the n term. So for the 50th term of the second sequence, we're going to write 11 multiplied by 50, which gives us 550. 11 by 50, this is 11 by 50, and we have 550. So for the second sequence, the 50th term is 550. We move on to the third one. Which is 8, 9, 10, 11, and so on. And the first term here, which is the starting point, is 8. The rule here is add 1. If we look at it, we discover adding of 1 gives us the next term. You add 1, get the next term. So the rule is add 1. So for the nth term, we're going to pick the rule, which is 1 multiplied by n. Then we now compare the rule and the starting point. This time around, they are different from the first two sequences, because in the first two sequences, the starting point and the rule, they are the same thing. But this time around, the starting point is greater than the rule. So we now look at 1 and think of what we can do to 1 to make up 8, which is the starting point, which is the first term. So when we add 7 to 1, we'll get 8. So since that is the case, the first term will now be 1, which is the rule, multiplied by n plus 7. Because when you add 7 to 1, you get 8. So finally, we have the rule to be 1 multiplied by n give us n. You can call it 1n. So 1n is the same thing as n plus 7. So this is for the nth term. So for the 50th term, we're going to write 50 to replace n here. So we have 50 plus 7, which is equal to 57. And lastly, we move on to the fourth sequence. Okay, for the fourth sequence, the starting point is 4. The rule is, if you look at 4 and 11 and 11 and 18, just examine the terms, you discover the relationship they got is addition of 7 to get the next term. So the rule is add 7. And the nth term of the sequence now is, since the rule is 7, it will be 7 multiplied by n. So just look at the rule, which is 7, and the starting point. You discover the rule is greater than the starting point. So what can we do to this rule to reduce it to 4? It means we're going to subtract 3 from 7. We're going to subtract 3 from 7 in order to get 4, which is the starting point. So we're going to write minus 3 here. And lastly, the n term will be 7n minus 3. That's the last term. That's the nth term rather. The nth term is 7n minus 3. Since the rule is 7, we have 7 multiplied by n. And looking at the rule and the starting point, they are not same thing. The rule is greater than the starting point. So what can we do to the rule to get 4? In this case, we are not going to add. We're going to reduce the rule in order to meet up to the starting point. And so to reduce it, we're going to take away 3 from 7 in order to get 4. And that's why we have the nth term of the fourth sequence to be equals to 7n minus 3. So lastly, now we can calculate the 58th term, which is writing the n term and replacing n with 50 minus 3. So 7 by 50 will give us 350 minus 3, which is equal to 347 viewers. And it told us when we have the n term, any number of term given can be calculated. I can say producing the n term of a particular sequence is the major task, because by the time you're able to produce the n term, any other term of the sequence can be calculated easily with just some arithmetics. So that's fine, viewers. Keep watching, liking, sharing, and subscribe to my YouTube channel. Bye.